Minglaba. In these videos, I'm going to talk about one particular terminology that we use to measure the machine learning model performance. As a beginner, as a student, one of the challenge that in learning the machine learning model is the terminology. Machine learning and AI has a lot of new terminologies that new beginners are not very familiar, and it makes a lot of people get confused. So in these videos, what I'm going to talk about is bias variance trade-off. All right. So before we start talking about bias variance trade-off, let's start with what we want to achieve when we talk about the machine learning model performance. Let's focus on supervised machine learning, which is the classification and regression. What is our goal for classification? Our goal for classification is simple. We want to reduce the misclassification as much as we can. Likewise, for regression, the objective of regression is to reduce the error between the predicted values and actual values. If you are still not very familiar with the metrics used for classification and regression, you can refer to the videos that I put it in the video description. Right, there are a few metrics that we use for the measuring the machine learning model. But in this video, let's focus on the next step, what we are going to talk about. So in this video, we have to remember that our objective of classification is to reduce a misclassification. For the regression is to reduce the error between the predicted and actual values. So how do we achieve it? We try to fine tune the parameters to get the best result as we can. But there is a problem. When you are trying to reduce, when you are trying to find the best model for the training data set that you have, you might see the inconsistent performance in the testing data set that you use it to test. All right, so let's see this bias variance terminology. The first terminology that I want to highlight in this video is called bias. What is a bias? Bias is measuring whether you are capturing the general trends or you are capturing the underlying patterns in the data. So if your model has a high bias, you generalize the model. So if the model has a high bias, okay, it may not capture the underlying patterns in the data. For example, you have the data and you are modeling with a linear regression model. It's a generalized version. All right. It does not capture the underlying patterns in the data. So our goal is we want to achieve our model to have the low bias. For us to be able to capture the underlying patterns in the data, of course, we can develop a more complex model, right? So that it can capture all the underlying patterns in the training data. But let's see another terminology that we have to bear in mind. Another terminology that I want to introduce here is called variance. What does a variance mean? Variance measure the performance differences between the training dataset and testing dataset. If your model has a high bias, that means your models perform pretty well for your training dataset. But it shows the inconsistent performance for the new dataset that you are going to test. This model is called high bias. Sometimes we call them as a overfitting model as well. So what do we want? We want to have the low bias. We want to reduce the performance error between the training dataset and testing dataset. We want to get the consistent performance, no matter whether you are doing it on the current training dataset or new dataset. This kind of model is more robust and stable, and we can have the reliable prediction even on the new and ancient data. So what we want to achieve is low bias, low variance. But these two doesn't come together. They go in the different direction. So what we have to do is we have to find the trade-off between bias and variance. We have to find the model that can lead to better generalization, but still perform well on the new and seen data, right? So we want to have the model which has a low variance. So this model must be able to perform both training and unseen data. But at the same time, we still want to capture the underlying data in the training pattern data as much as we can. All right. So we have to find a model which has the low bias, low variance. But like what I mentioned, these two are not going together. They are going in the opposite direction. If your model has a low variance, let's look at this one. Okay. In this graph, what we are demonstrating is we are demonstrating the performance of the models, performance of a regression model with the different orders. So at the very low orders, order number one, which is basically a linear regression model. In this case, the model has a low variance. If you see the green color circle, um, they have a low variance. What do you mean by low variance? This model perform the performance of this model on the training dataset and testing dataset is consistent. They are quite similar. But on the other hand, if you look at on the bias side, you have the high bias. That means the performance on the training dataset is not very good because it's too generalized. They don't capture the underlying patterns of the training dataset, right? So you can see that when we want to achieve the low variance, the models tend to have the high bias. So now we increase the degree of the models. So let's look at the degree order 6. All right, degree order 6. In this case, what we are observing is that we have the low bias. That means the model performs and capture the underlying data of the underlying pattern in the training data. The model capture well for the underlying patterns of the training data. That's why it performs pretty well. You can see the low bias. But the performance between the training and testing data are not consistent. This you can see it by the red color curve. All right, variance is pretty high. So when we try to reduce the bias, the variance go up. In other words, when we're trying to fit our model to the training data as much as we can, the performance consistency between the trainee and testing became bigger and bigger. All right. So the objective of machine learning model performance fine tuning is to find the parameter, to find the hyperparameter that provides low bias, low variance. In this particular case, we can see the order degree 4 has the lowest variance and lowest bias. Okay, at degree 4, you have the both low variance and low bias. It's not the lowest, right? It's not the lowest bias. Of course, if you are talking about the bias alone, degree 6 has the lowest bias. But here, what we are trying to find is we try to find the point where both bias and variance are lowest. Okay, so in this case, the model that you should choose is the model which has the degree 4. Right? I hope this helps you understand how to fine-tune the hyperparameters by looking at the bias variance trade-off. Right? So of course, one of the methodology that we use to reduce the to find the to reduce the overfitting problems, to find the optimal solution for both training and testing data set is called cross-validation. This cross-validation will be explained is actually already explained in another video that I will share on the comment box. You can refer to that. Thank you very much.